All right, guys. Chapter 4, Section 5, talking about rational exponents and radical functions. We're going to talk about finding solutions or zeros. Anybody know what solutions mean? What does that mean? To find the solution. Finding the zeros. It's the answers, y'all. Answers. What does x, equal? That's all finding the zeros means. You will see the question, what's the answer? What does x equal? You'll see that written a few ways. The word zeros, solutions, roots, and one more. Anybody know? What's it called where the graph crosses the x-axis? X-intercepts, all right? That question can be asked 4 different ways. So if you see something on your test or quiz that says find the solutions, that means what does x equal? If it says find the roots, that means what? What does it mean if I say find the roots? What does what equal? X, okay? If it says find the zeros, what does x equal? So sometimes you're going to talk about real answers. Sometimes you're going to talk about imaginary. Have you guys seen imaginary numbers yet? With the eyes and stuff? Okay. And we're also going to talk about rational and irrational. I always like to think about it as rational numbers are pretty, irrationals are not pretty. Can you put your finger on this point exactly on the graph? That's what irrational numbers are not. So when we look at something like this, solving a polynomial equation by factoring, however you're going to solve it, we're going to talk about 2 ways today, rational root theorem and factoring. What did I tell you yesterday about the highest exponent? What does that tell you? How many answers you should have. So at the beginning, you should know, when I am done with this problem, I should have 3 x values. That's a really, really good thing to keep in mind. So when we're factoring, what's the first thing we ask ourselves? Is there a GCF? Is there one? 2x, perfect. So take that 2x out. Remember, it doesn't go anywhere. It just comes out in front. And then divide everything by 2x. If you want to write it underneath, you can. If you don't want to, you don't have to. But I'm left with what here? X squared minus 6x, correct? Plus what? Plus 9, okay, equals 0. So now we're left with a trinomial. If I have a trinomial, what do I try to break it down into? 2 binomials, perfect. So we take our A times C. 1 times 9. What are the factors of 9 that multiply to give me a positive 9, but add to give me a negative 6? What kind of 3? Negative, negative. Good. What goes in the front of each parenthesis? X's. Now, I have fully factored this problem, but I have not found the solutions of the roots of the zeros. What do I do now with each piece? Set it equal to what? Perfect. All right, now we're going to talk about these answers here. So here I divide both sides by 2. I got x equals 0, correct? Here I'm going to add 3 to both sides. So I get x equals 3. And here I add 3 to both sides. And I get x equals 3. How many answers do I have here? 3. How many did I tell myself at the very beginning that I was going to have? 3. Now, have you guys talked before? I don't think this one says to sketch, but have you talked before about multiplicity? Okay, what does multiplicity mean? If you have multiples of something, do you have it just once? No, you have it more than once, right? So in this case, do we have multiplicity here? Yes, you have multiplicity of x equals 3 2 times. Now that means something for a graph, right? So just think about this. Here's my graph, right? You have an intercept here at 0, and you have one here at positive 3. Did you guys talk about end behaviors of a graph? What the ends of the graph do? Okay, we'll talk about that a little more. Right now, I'm just going to talk about what the action, we call it the action at the x-axis. This graph is going to do something here, and it's going to do something here. If you have the same answer an odd number of times, here I have x equals 0 1 time. Is that an odd number or an even number? That's odd. If you have an answer an odd number of times, meaning 1 time, 3 times, 5 times, it's going to go through the x-axis. Your graph will. If you have the same number a multiple times that's even, like I have the same thing 2 times, 4 times, 6 times, what's going to happen here is it's going to, we say, touch and turn. Another way you can say it is that it bounces off the x-axis. So if I'm talking about end behaviors here, I like to think of it this way. I don't know how Ms. Carver does it, but this is how I like to think of it. I always think about a line, right? Think about a line, and then think about a parabola. What's the difference in the arrows there? Okay, in a line, your arrows are going in opposite directions, right? So I think of the word odd. And then in a parabola, they're going in the same direction. So I think of the word even. So what I do is at the very beginning, I look at my first term here. It's 2x cubed. Is that an odd number or an even number? Cubed. It's odd. Is it positive or negative? The 2. So it's going to resemble, the ends are going to resemble like a positive line. They're going to go in opposite directions, and it's going to be sloping upwards. So that's your end behavior for this graph. It's going to be rising on the right, falling on the left, falling on the left, rising on the right. So if you were going to graph this, you're down here and you're up here. Tell me what my graph is going to do when I come here from this arrow and I go to 0. Is it going to go through it, or is it going to touch it and turn? It's going to go through. So it's going to come here and go through the x-axis, goes up however high, and then what's it going to do when it comes back here to 3? It's going to touch and turn. It's going to bounce and go back up. So that's why when you're asked to sketch a graph, it's really important to identify what the ends of the graph are doing and then what's happening at the x-axis where it crosses. Is it going to cross through, or is it going to touch and turn? So we're going to do every one of these that we do to solve. We're then going to just sketch a little graph just to kind of get you guys in the habit. So let's look at the next couple. All right, repeated solution. We just talked about this. Everything I just talked about. It's right here. Question?
Oh, no, I'm good.
Okay. So remember, if you have x an even number of times, meaning twice, 4 times, 6 times, whatever, it's going to touch and turn, right? Touch and turn, or we can say bounce. If you have x an odd number of times, 1 time, 3 times, 5 times, it's going to do what at the x-axis? Go through the x-axis. All right, you guys see that? All right, we're going to talk about behaviors of everything, and then we're going to find the zeros and do a little sketch. So let's talk about end behaviors first. How do we determine end behaviors? I'm going to pretend like you guys have never seen this before, just for a little review. When we talk about end behaviors, you look at the leading coefficient as long as your equation is in standard form, meaning the highest exponent is first. So when I see my leading coefficient, I recognize 2 things. First of all, the highest exponent is what kind of a number? It's even. So when I think about my end behaviors, even means the arrows are going in the same direction, either both up or both down, correct? You guys with me? Okay, so is this going to be going in the same direction up or in the same direction down? Why down? You're right. Because the 2 is negative. Perfect. So you know your end behavior is like this. We would say it's falling left and falling right. You always read left to right like you do a book. So you know that when you make your little sketch, both of your arrows are going to be going down. Again, we figured that out because you identify the highest exponent. Is it even or odd? That tells you if they're going in the same direction or opposite. Since this is an even number, I know they're both going either up or down. And since the 2 is negative, I know they're both going down. Everybody with me? Okay, so now let's talk about solving this. How many answers should I have?
4.
Why 4?
Because the exponent.
The highest exponent is 4. That's telling you, okay, I have 4 answers. I might have multiplicity or something like that, but I do have 4 answers. So let me rewrite the problem. Negative 2x to the 4th plus 16x squared minus 32 equals 0. All right, first thing we ask ourselves is there a GCF? Is there something I can take out of all 3 of these? What kind of 2? Negative 2. If we lead with a negative, guys, get it out. It makes our factoring so much easier. So I have left x to the 4th. What? minus 8x squared plus what? 16. Why do my signs change, guys? Because we took out a negative. We divided out a negative. Sometimes it's helpful to write your number that you're dividing underneath so you can see the sign change. So this -2, still hanging out here. We're leaving it out there. I have a trinomial. Whenever I have a trinomial, I always try to break it up into what? 2 binomials, okay? So think about what's going to go in the front of both of my binomials. X squared. Why isn't it just x? Because we need x to the fourth. X squared times x squared gives you x to the fourth. So now let's multiply a times c. 1 times 16. What are the factors of positive 16 that will multiply to give me positive 16, but add to give me a negative 8? What kind of force? Both negative. Good. All right. Are we completely factored? No. What do I have left here? The difference of perfect squares. Think about that, guys. If you're left with 2 terms, you check to see, are they both perfect squares? If they are, great. If the middle sign is a minus, then you're like, oh, wait a second. I can break that down even more. So what does my first parenthesis become? And my second? X minus 2 and plus 2. Perfect. Then what's the second set become? X minus 2 and x plus 2 equals what? 0. All right? We have fully factored this, but we have not answered the question yet. The question is, what are the zeros? So now what do I do with each piece of information that I have? Set everything equal to 0. Watch what I do here, guys. -2 equals 0. X minus 2 equals 0. X plus 2 equals 0. X minus 2 equals 0. And x plus 2 equals 0. Does -2 ever equal 0? No, so this is not part of our solution. If there was an x with it, like in the last problem, do you remember we had x equals 0? You have to be careful. Just because you factor something out in front doesn't necessarily, it's always going to be x equals 0. It has to have a variable with it. That's why I always set everything equal, just so I make sure I see. So in this case here, I have x equals 2. Here I have -2. Here I have positive 2. And here I have -2. Do I have 4 answers? Yes. Do you guys see that? What do you notice about your 4 answers? 2 of them are the same, right? So you have multiplicity at x equals 2, 2 times. And you have multiplicity at x equals -2. How many times? Say it again. 2 times. Now you guys are like, why is that a big deal? Well, what does that mean? What's going to happen at the x-axis when your graph touches -2? Is it going to bounce off of it, go the other direction, or is it going to go through? It's going to bounce off because you have a multiplicity an even number of times. What's it going to do here? It's going to bounce as well. Why is this important? Well, think about graphing this. Where are my intercepts? Where does this graph touch? At x equals what? 2. And at x equals what? -2. Way back at the beginning, what did we say our end behavior was? Both the arrows are going in which direction? Down, okay. So, let's think about this. Think about what this means. Your directions of the arrows is down. If you want to make them further down like here, doesn't matter. So when you draw your graph, tell yourself now, what are you doing when you hit -2 and what are you doing when you hit +2? You're turning. You're not going through it. You're going to come here and you're going to hit this and you're going to bounce and go down. Don't worry about how far down you go. We're not worried about intercepts. Just go down and then you're going to come up here and hit it and you're going to do what? You're going to go back down. So you can visually see your end behaviors are both down, which you said at the beginning. You do have 2 intercepts where it touches the x-axis, but since you have the multiplicity of 2 times at each of those, it touches the x-axis and goes the other direction. That's why that's important to know how many times you have the same answer. If you would have had it only one time, it would have gone up and gone through and then come back down. Questions? Let's scoot along, scoot along. All right, this just asks us here to solve the equation. We might talk a little bit about end behaviors and stuff like that. Actually, we will. Just tell me, highest exponent is what? 4. Even or odd? Even. So both of the arrows are going in which direction? The same. And which way are they going, up or down? Why? Because the 4 is positive. Perfect. All right, so if we're going to answer this question, how many answers do we have? 4. Your highest exponent is 4. You should have 4 x values. First thing we look for is GCF. Perfect. What do I take out? All of them have a 4. Awesome. So I leave that 4 out in front. 4 divided by 4, it leaves me with x to the 4th minus 10x squared plus what's 36 divided by 4? 9. Good. All right, I'm left with a trinomial. Leave that 4 out in front. A trinomial we try to break down into 2 binomials. What times what is going to give you x to the 4th? Perfect. What are the factors of positive 9 that are going to multiply to give me a positive 9 but add to give me a negative 10? You just tell me. You don't have to raise your hand. Negative 9, negative 1. You agreed? Okay, perfect. Are we done? No, we're not fully factored because I see, oh, wait a second. I have an x squared, or I have something squared, and then a minus sign, and another something. Are both of those somethings, my first term and my second term, perfect squares? Yes, and since there's a minus sign in the middle, I'm going to check to see if it's the difference of perfect squares. Is it? Yes. What times what gives me x squared? X and x. What times what gives me negative 9? Plus and minus 3. Perfect. What about my x squared minus 1? That's the one that we miss a lot. X and x. Good. And plus and minus 1. Good job, guys. Now we're fully factored. So what do I do with each piece, each parenthesis? Okay, so 4 equals 0. X plus 3 equals 0. X minus 3 equals 0. X plus 1 equals 0. And x minus 1 equals 0. Tell me about 4 equals 0. Does not. Nope, not part of our solution set. So here I'm at negative 3. Here I have positive 3. Here I have negative 1. Here I have positive 1. How many answers do I have? 4. Do I have multiplicity? Yes or no? I do not. Do I have any x value that is exactly the same? No. There's a huge difference, guys, between negative 3 on a graph and positive 3. So there's no multiplicity if you were asked. What does that mean is going to happen at each one of these points on your graph? Is it going to bounce or is it going to go through? It's going to go through. So think about this. We're at negative 3, negative 1, 1, and 3, right? What did you say at the very beginning the end behaviors were? Both up. So we're here and here. So I'm going to come through negative 3, back up through negative 1, down through 1, back up through 3. We do not bounce at all. We go through. Does that make sense? We okay? All right, scoot along here. What about this one? What do I have to do first? I got to move this 14x cubed over. I cannot do anything, solving anything, until everything is on one side of my equal sign and it's set equal to 0. When we move this over, I have 2x to the 5th minus 14x cubed plus 24x equals 0. Right? It was positive. We move to the other side of the equal sign, we get a negative. And now let's just go through the process for the 20th time. What do I look for? GCF. I'm going to take out a 2x. I'm left with x to the 4th minus 7x squared plus 12. You guys agree? Okay. How many answers should I have here? 5. Okay. So I have my 2x out in front. I have a trinomial. Let's see if we can break it down into 2 binomials. What times what is going to give me x to the 4th? X squared. And then what times what is going to give me a 12 when I multiply, but a negative 3 when negative 7 when I add?
Negative 4, negative
-4, -3. Sometimes tell the answer when I don't mean to. Okay, so now I have 2x out here. Is x squared minus 3 the difference of perfect squares? No, so let's just leave it. Is x squared minus 4 the difference of perfect squares? Yes. What does this break down into? X plus 2 and x minus 2. God bless you. If you wanted to, or if it says to absolutely fully factor, and I'll show you this in a second, this is actually x minus the square root of 3 and x plus the square root of 3. Square root of 3 is a gross number. We'll talk about that a little more in a second here. But what do I do now? Don't worry about the green that I just wrote. What do I do now with each piece in red if I'm going to try and find the answers? Equal to 0. So 2x equals 0. X squared minus 3 equals 0. X plus 2 equals 0. X minus 2 equals 0. Everybody with? Okay, so divide both of these by 2, and I get x equals 0. Do you see how, guys, we took out not just a 2, we took out a 2x. If you have a variable that you divide out in front, that will constitute an answer. Here, I have x squared equals 3. How do I find my answer here? Take the square root. When you guys physically put the square root on, what goes in front of your answer? Plus or minus, so square root of 3. Here I have x equals -2, and here I have x equals +2. Do I have 5 answers? Yes, because this is really positive root 3 and negative root 3, right? Do I have any multiplicity? No. Are any of them exactly the same? No. Is this pretty to put on a graph? No. Could you estimate it? Yes. But it's not pretty. You can't just put your finger on it and say, oh, it's exactly right here. What's going to happen at every one of those intercepts on the graph? It's going to go through. Good. All right, let's go through these a little quicker. Find the zeros. What does that mean again? The solutions, the answers. It says sketch the graph. So let's think about what our graph is going to do. Highest exponent is a 4. So what are the end behaviors? Both up or both down? Why are they both up? Because it's positive. Perfect. How many answers should I have here, guys? 4. All right, so I have 3x to the 4th minus 6x squared plus 3 equals 0. Can I factor anything out? 3? Okay. Bring that 3 out. X to the 4th minus 2x squared plus 1. You guys agree? I have a trinomial. We want to break it down into 2 binomials. So what goes in front of each? X squared. Good. And then what's going on here? What times what is going to give me a positive 1 when I multiply, but a -2 when I add? -1. Good. Can I factor any more? What's this first x squared minus 1 going to become? Perfect. Plus 1 minus 1. What's the second x squared minus 1 become? Plus 1 minus 1. Awesome. And now what do I do with each piece? Set equal to 0. So again, 3 equals 0. When I took out that 3, did it have a variable attached to it? No, so this is not going to give us a solution. But I am going to get solutions here. X equals -1, right? And this one's going to give me x equals +1. And this one's going to give me x equals -1. And this one's going to give me x equals +1. What do we notice? Multiplicity there. And then what do we notice here? Multiplicity there. So let's talk about our graph. I'm at +1 here, -1 here. What'd you tell me my end behaviors were? Both where? Both up, up. What's it going to do at -1, guys, and at +1? It's going to touch and turn. It's going to bounce. We don't know how high it's going to go. No big deal, but it's going to come down here. It's going to boop, bounce off, go back up, come here, and boop, bounce off, and go back up. If you wanted to find the y-intercept to know exactly where it was, to find the y-intercept, you plug in 0 for x. God bless. So here it would be at 3. God bless. But you don't have to right now. We're just worried about what it's doing at the x-axis. All right, what about here? End behaviors. Same direction or opposite? Opposite. Okay, is it a positive x cubed or a negative one? Positive. So it's going to resemble, the ends are going to resemble a positive line. So it's going to be going down on the left, up on the right. How many answers should I have? 3. Okay, so x cubed plus x squared minus 6, x equals 0. What can I take out? Perfect. X squared plus x minus 6. Can I factor this trinomial? What are my factors of negative 6? That multiply to give me negative 6, but add to give me a positive 1. Plus 3 and minus 2. Perfect. Fully factored. Now how do we find all the zeros? X equals 0, x equals negative 3, and x equals positive 2. You guys agree? Do we have multiplicity? Nope. So what's it going to do at each x value? It's going to go through or bounce off? It's going to go through. If you do not have multiplicity an even number of times, if you only have 1 time or 3 times, it's going to go through. So what were your end behaviors again? On the left side, it's going downward. The right side, it's going up. And it's going to go through each point. So come up and go through here, through here, through here. Get your little picture. All right, next one. We're going to talk just for a second, and I'm going to get through these next couple slides, and then we'll be done and we'll finish up tomorrow. But we're talking about something called the rational root theorem. It's also referred to as P over Q. Look at this. P is the factor of the constant term. Let's say this in high school terms, the last term. Q is the factor of the leading coefficient. Where's that? It's the first term. All right, for our purposes, every single time we do this, I believe, I got to make sure 100%, but my pre-cal's different. But for what we do in Algebra 2, since we're just learning this, the leading coefficient is going to be 1. And that'll help things because we don't have to use fractions and stuff. But there's going to be times when you guys get something and you can't just take out the GCF and all that stuff. There's a way that we have to do this using the rational root theorem or something called over Q. So the first thing I want to do is just look at a problem like this. If I gave you this problem and I said, okay, guys, factor it. Well, how many answers should you have? 3. You should be able to tell me the end behaviors and everything. So since I have 4 terms, right, the first thing we do is GCF. Is there one? No. So then you guys would tell me, oh, well, no big deal. We'll just group it. So I would take out, you don't have to write this down. You guys would agree, take out an x squared, and then we're left with x minus 8. What would you take out of 11x plus 20? Ooh, this one's not going to factor. So before today, or whenever you guys first learned this, you would say, oh, it's not factorable. I can't figure it out. But you can figure it out. You're going to use something called the rational root theorem, or P over Q, where what you do is list out all the possible answers there could be, and then we use synthetic division to figure out one of them. Once you figure out one of them, the other ones become evident. So when I say P over Q, all right, we're going to list out all the possible answers now, just the possible ones. It could be a combination, and it's always plus minus. So plus minus. What is your P? What's the last value? What is the last value? 20. And what is the first value? 1. So you're going to list out all the possible values. You always put a plus minus in front because it could be positive or negative. So the possible zeros, the possible answers I could have are 1, 2, 4, 5, 10, and 20. Now you guys are sitting here thinking, I have to do synthetic division that many times? No. What we're going to do is methodically use synthetic division, and once you find a remainder of 0, what does that tell you if your remainder is 0? That it's true, it is a factor, and then you'll see how it'll work nice and easy. Let's do one. Is it this problem? All right, we'll do 2. Okay, find all the solutions. So this is number 5. X cubed minus 5x squared minus 2x plus 24 equals 0. My first suggestion to you guys is always see if it does factor. For our purposes right now, it doesn't. All right, it does not. We'll do 6 tomorrow. I just want to get through 5, and then we'll pick up with 6 tomorrow. It does not factor. So we have to say, okay, wait a second. What are the factors that I could possibly use here? Well, there's no GCF, it's not going to group. So P over Q. Our P is 24, our Q is 1, right? So what are the possible factors of 24? What times what gives me 24? Well, 1, 2, 3, 4, 6, 8, 12, and 24. So now we're going to use synthetic division. I personally think you should start with 1. If 1 doesn't work, go to -1. Then go to 2, -2. If you jump around, you would waste a lot of time and you could get yourself lost. You might be lucky and happen upon the right answer, but I think you should methodically go through and say, okay, this 1 doesn't work, go to 2. 2 doesn't work, go to 3 till you find the answer. So let's work this out. Let's try +1. Synthetic division. Write out your coefficients. 1, -5, -2, and 24. Do I have any gaps that I have to account for? Right? I go x cubed, x squared, x to the first. Okay, good. So bring down the 1. 1 times 1 is 1. -5 and 1 is -4. -4 and 1 is -4. -2 and -4 is -6. -6. Is this going to give me a remainder of 0? Okay, go ahead and go to the next one. Let's try -1. 1, -5, -2, 24. So bring down your 1. 1 times -1, -1. -5 and -1, -6. -6 and -1 is 6. -2 and 6 is this going to give me a remainder of 0? Okay, go to 2. 1, -5, -2, and 24. 1 times 2 is 2. -5 and 2 is -3. -3 and 2 is -6. What's -6 and -2? -8. -8 times 2, is this going to give me a remainder of 0? No, okay. That's okay. Keep going. 1, -5, -2, 24. Bring down your 1. What's 1 times -2? What's -5 and -2? What's -7 and -2? 14. Positive. -2 and 14. 12 times -2. Woo! What do we find out here? What's one of my solutions? X equals -2. We found one of our solutions to be x equals -2. How many solutions are still left to find? 2. Because at the beginning we had x to the third. So I have 2 more solutions to find. So here is my resulting polynomial here. If I started off with x cubed, my answer starts off 1 less. So x squared, x, constant, remainder. How would I write what's left over? What's my polynomial? X squared minus 7x plus 12 equals 0. When you get to this point, guys, you have 2 options. 1, since it's a quadratic, it will factor. If it doesn't factor, what is that formula we have to use? The quadratic formula. If only, when you get here to x squared, if this does not factor, you have to use the quadratic, which might be a possibility. Let's hope this factors. This is a trinomial. Can I break it down into 2 binomials? What times what would give me a positive 12 when I multiply, but a -7 when I add? X minus 3 and x minus 4. So what are my other 2 solutions? X equals 4, x equals 3. How many total solutions do I have? 3. What's going to happen at the x-axis at all 3 of these? Going to touch and turn, bounce off, or is it going to go through? It's going to go through. Good. So all your P over Q is just synthetic division repeatedly until you find a remainder of 0. Once you find a remainder of 0, I'd say 80% of the time, whatever's left over will factor. Sometimes when you have a higher exponent to the 4th, it won't. You have to do it again, something like that, or you might have to use a quadratic. But a lot of the times, you'll be able to factor what's left over. Does that make sense? All right, we'll pick up with the last example, and then I think there's like 3 more slides to do tomorrow. And then I will get you a quiz review or something together for Thursday, and you guys will be ready for your quiz on Friday. Sound good?